Probably help if I say I'm going to record or record. All right, so this is F. This is F prime. Look at this. If F is increasing, follow me, follow my cursor. If F is increasing, notice how the derivative is positive. Look, when F starts, follow me, when F starts decreasing, the derivative is negative. What's the derivative right here at this horizontal tangent? 0. Notice how it matches the 0 of the derivative. So getting all here. So for what values of x is F increasing? So we're going to list the intervals where F is increasing. So it's increasing from where? 0 to 1. Let's write that in. From 0 to 1. Where else is F increasing? From 6 to where? 6 to 10. Okay, from 6 to 10. What is the behavior of F prime on those intervals? What's F prime's behavior? What would we say? F prime is positive. F prime is positive. Okay? So let's conclude this, that we already know this. We already know this, but let's conclude it. When F is increasing, what do we know about F prime? F prime is positive. In the same way, if the derivative is positive, the original function is increasing. Okay? For what values of x is F prime negative? So let's look at F prime, which is down here. Where is F prime negative? From 1 to 6. So we're going to say that. From 1 to 6. What is the behavior of F on those intervals? So from 1 to 6, go to F. What was our graph doing? It was decreasing. So we can conclude when F is decreasing, F prime is negative, or we could say the other way. When F prime is negative, F is decreasing. I think the visuals really help. Now here we go. Next thing. This is going into what we talked about last class on Wednesday. For what I almost fell down here sitting down. I don't know if anybody else is watching me struggle there. For what values of x is F prime? So come down here. When is F prime increasing? From 3 to 9. So from 3 to 9. So let's write that down. From 3 to 9. From 3 to 9, what's the behavior of F? It's what we learned last class. It's concave up, isn't it? Isn't that the definition? When F prime is increasing, F is concave up. So we can say concave up. So what can we conclude again? It's what we talked about. When F prime is increasing, we can conclude F, can I use CU, concave up? So let's look at F now. Where is the graph of F concave down? I think we got a couple intervals where it's concave down. So here's F. I'm concave down from 0 to 3. Does that look right? From 0 to 3. And then, okay, from 0 to 3. And from, it's hard to tell, but from right here you can see there's a point of inflection. It changes its curvature from 9 to 10. What is the behavior, and you can see it here, what is the behavior of F prime in those intervals? F prime is decreasing, and from 9 to 10 it's decreasing as well. Okay? So it's decreasing. Which allows me to conclude if f prime is decreasing, f is what? Concave down. Now, where does f have a local maximum at? Where does f have a local maximum? Which is a relative max. Local is the same thing as relative. The local max where at, guys? 1. What do I know about f prime there? It's what? F prime is what? 0. Okay? Now that's all the questions I asked here, but let's talk about this. Let's follow me here. Let's go to so right here. Here's a relative minimum at 6. I have an x-intercept also at f prime at 6, right? Where are my points of inflection? So this is, we don't talk about it. It's not on the question. Where's my points of inflection? So look here. We changed concavity where? We changed concavity. It was concave up from where? 3 to 9. And it was concave down from 0 to 3 and from 9 to 10. So my points of inflection are where? At 3 and 9. Look at F. Can you see the points of inflection? Does that look like at 3 and 9? Okay, look right here and right here. Everybody follow me on that? Now, look at F prime. Oh. F prime has a horizontal tangent there. That means the second derivative was 0. And it went from decreasing to increasing. There's a point of inflection. F prime goes from increasing 0 to decreasing. There's a point of inflection. Y'all follow me on that? So, just want to make sure we're clear on that. Did that help? Okay, I'm going to save this video.